Welcome to Introduction to Multithreading with Python. This video assumes that you know the basics of Python and you have some knowledge regarding operating system threads. If not, don't worry, we'll be covering it along as we go. Um, I am using Ubuntu operating system. My Python version is 3.11, the latest as of recording this video, and I have set up virtual environments and I'll be using VS Code for most of the coding that we'll do. Uh, this video will not cover advanced concepts like thread synchronization and synchronization primitives like semaphores. Subclassing the thread class is excluded, and thread pool executor class will also not be covered. Uh, then what will I be covering? We'll take a look at the threading module in Python, just the basics, and after covering some of the concepts, we'll be creating a small game to bring all of the concepts together. So let's start by asking ourselves this question, that what is a thread? So a thread is a lightweight process you can imagine, and the reason why it's lightweight is because it does not cause any context switching overhead, because it uses the same data segment and the same code segment of the process. So if you switch between threads, there's not much context switching involved. Moreover, the thread also has its local data, which is not shared by the other threads. But as we mentioned that they reside in the same process, so they have a shared memory with that of the process. And why do we use threads? We use them mainly for performance reasons. So if you have a task and we would like to distribute it, so in that case we could spawn multiple threads and then those threads could do the task for us quickly. Threads are also used for long running tasks which are not very critical and they run in background. We'll be covering them in more details. Then let's get started with the main thread. So I have a hello world program here. Let me print the hello world. Let me run it, see if it runs. Now, my question to you is, how many threads were created in running this hello world program? So the answer is there was a thread involved. We did not create it, however, it was already there. It's the implicit main thread that runs this program. So let's take a deeper look at this main thread. So for that, let us import the threading module, and let's get the current thread. Let's call it threading dot current thread. So this will bring the current thread into this variable thread, and let's analyze that variable now. I've kept a breakpoint here so that we can look at the different properties of this thread. Now, what all properties does this thread have? So it has a name, and it's called main thread. It has a identity or ID, as you will, This is Python generated, and you can also see there is a native ID here, and this native ID is generated by the operating system. So this is the real ID which is given to this thread by the OS. We could very well verify this. So let me go to the terminal and let me say ps-p, and we already have the uh, native ID here, which is the same as the process ID 14742, and let's print the commands and the args that was used to call this. So as you can see that this is the same Python interpreter that I'm using. I can verify it here. It's Python threading main.py. So I'm using a virtual environment, so it's pointing to the binary which is present at this location. And also, if we could import the OS, and then if I say os.getPID, so we see that it's the same ID which is returned by the native ID of the thread. So that's about the main thread, and it's already there implicitly. We just took a deep dive in it and we saw all the different properties. Um, yeah. Now let's take a look at spawning a simple thread. So let me delete this, and let's make a counter which says, let's make a function which counts from 1 to 5, let's say, for I in range 5. Print I, and also sleep for 1 second. We'll have to import time module, save it, and now the way you use or spawn a thread is you create a thread object. So let's create a thread object from the threading dot thread class, and we give a target. The target is the function name which you want to run as a thread. So we'll give the name as counter, and the thread is created, and also for our sake of understanding, also print end of program. Now if I run this, you will notice that nothing happens. The reason is that we have created the thread object, but we haven't started it yet. So let me start that. So now we have our values printed here. Notice that the end of program was printed before these values got printed. Let's discuss this next. Let me check my notes. I'm missing something. Yes, let's discuss first the name of the thread. So we could also give a name to this thread, but before doing that, let me keep a breakpoint here and show you what is the name assigned by the Python interpreter by default. So let me keep a breakpoint here. So as you can see, it's named thread 6 here, and as the breakpoint is hit, the main thread as well as the thread 6, they both are blocked. So now let's try naming it. Maybe let's say we'll give a name as counter. Now let's check. Now the thread 6, the name got renamed, and now it says counter here. So you could name your threads. Now let's discuss the join method. So we noticed that the end of program was printed first, and then these values got printed. The reason being that as soon as we call thread.start, this is a non-blocking call. So it immediately exits out, and then we print the end of the program, and then the thread runs and prints these 5 values here. So we would like to wait, we would like to block till the thread completes. So in that case, we'll use thread.join. Let me remove the breakpoint. Uh, so the control won't come out of this line number 11 till it has finished, till the thread has finished printing all the 5 values, and then it will print the end of program. Now let's discuss how to pass arguments to this function. So imagine that I have, let's say, n, and then I want to run till n instead of running it till 5. So we have a args keyword, and args will take a list or a tuple. So let me give a argument as 5. And if I run it, it will throw an error. The reason being that this is not a tuple, it is parsed as an int. So in order to make it as a tuple, we have to put a comma, trailing comma at the end, and now this is a tuple. Now let's see if this works. Yeah, so it printed the values now. Okay, now the other concept which I would like to discuss is daemon. So let's go back to the way where this program was, and let me just comment this out, and let's run this once just to check the output. So it prints the end of program, and then it prints all the 5 values. Now even though we did not say it to join, it still waited for the thread to complete, and then the main thread exited. So at this point of time, after it prints end of program, there is nothing for the main thread to do because it has completed all its statements, but it is still waiting for this thread to finish so that it can exit out. Now consider a scenario where you uh, don't want to wait for this thread. You want to exit out the thread as soon as your main program finishes. So in that case, we could add a property daemon to true. Uh, so let me add that daemon is equal to true. Now let's check the output first. Now you can see here that it printed the end of program, and as soon as the main thread finished, it automatically exited out. Now why would you require a daemon thread? It could be used wherein you don't want to manage the thread itself, you just want it to run. And if it is for a non-critical application and the thread, the daemon, it silently ignores the error, then in that case we can use this as a daemon and it will work. We will be using this uh, in our game that we will be creating soon. So again, to recap, when the daemon thread is true, if a thread is marked as daemon, then it will exit as soon as the main thread exits. unlike non-daemon threads where it waits for the entire program to finish and then it exits. All right, so we moving on. So we also have a timer class. Let me let's take another file for that. Say timer.py. Now imagine a scenario where you would like to print something, um, or you would like to execute a task after a certain interval of time. So let's import our threading module. Say we have a task and the task is it just prints something. The task is executed. And let's create a thread object. Target is task. And when we say thread.start, it will start and it will print the task is executed, right? It will do it then and there. But we would like to wait for n seconds or some seconds before this task is executed. So for that, the threading module provides a timer which takes the first argument as I believe it's the time, it's the interval. So let's make it 5 seconds and then we can give the name of the function. So this will be printed after 5 seconds. Let's check it out. And there you go. So after 5 seconds we have printed this. Okay, so finally now whatever we have learned, we will combine it all together in a small game that we'll be making. The idea is that user will be presented with two single digit numbers and he has to sum them up and give the answer. And he has to do it in a set amount of time. Otherwise, his score will be, otherwise the game will be over. So let's get started. We name it game.py. Let's import our threading module. And let's see. So the um, so we would like to generate random single digit numbers. So for that we'll be also importing the uh, random int function, and let me create a method here which let's call it take user input or user answer maybe. And what it will do is it will generate two random numbers, so let's call it num1 random integer, and we want it to be between 1 and 9. So we have that, and number 2 is equal to random integer 1 and 9. Now we will ask the user for the answer. So let's print it out. Num1 plus num2 is equal to, and then we'll leave it at that. But we would like to take it as user input. So instead of print, we'll be using the input function and we'll be capturing the user answer in the answer variable. Let's say that. And that's it. Now we need to verify whether the user gave the correct answer or not. And based on that, we will be incrementing or decrementing the score. So that For that, we'll be having a global score object, and let's have a global score here as well. Now we will be and yes, this input returns a string, so we need to convert it to int. We should have sanitized the input here, but I'll assume that the input is never, it's always an int, so we can directly convert it without the try catch, try except blocks. Now let's check if the answer was valid. So if answer is equal to num1 plus num2, then in that case we'll be incrementing the score. Else and also let's print right, and else print wrong, and let's leave it at that. We'll not decrement the score. So this function generates two single digit numbers, provides it to the user, and based on what the number user has entered, it will increment the score, or it will just ignore it. So now this is the user input part. Now the logic for our main, let's see. So we would like to uh, run this like so a set amount of times. So let's make a for loop for that. So for I in range of, let's say, for now, let's say 3 times we would like to ask the user about this. Okay, and at the end, let's print out the score. Print score. Let's see if this works. So let me run this. So it says 7 plus 6, so that is 13. Oops. It says right, 3 plus 3 is 6, so let's make it 7. And 3 plus 2 is 5, so let's make it 5. So that works. But we said that we would like to have it timed, right? So that if user takes more than, let's say, 3 seconds or 5 seconds, then in that case the game should automatically say that your time is up, and it should report the score, whatever is there at that point of time. So how can we do this? So previously we looked at the timer concept, that it will execute a task at after a particular amount of time. So what we could do is we could start a thread after, let's say, 5 seconds, or maybe 3 seconds, and in that thread we could say that your time is up, right? So let's say that this is our time is up function, and in that as soon as it comes here, then that means that the user's time is up. So we'll be printing that, and for now uh, let's see how it behaves, right? And also we need to create a thread for this. So let's first get our timer running, and let's convert this user answer to a thread. So let's call it answer thread, threading dot thread user target is equal to user answer, and we have a timer thread which is nothing but threading dot timer. Let's make it 3 seconds, and the target is time is up. And as noted previously, we need to start those threads. So let's start this thread, and also let's start the timer thread. So let's see how this will work. Um, so the timer thread will start and the answer thread will start at the same time. What we would like to do is uh, we would like to wait for this answer thread, and if the answer thread returns to us before the timer thread has executed, then we should cancel it. And I forgot to mention earlier, in this timer thread, when you start the thread, you have the ability to also cancel it. So what do I mean by that? So for example, let's say that so we have a timer thread which will run after 5 seconds. So we will sleep for maybe 3 seconds, and then we could cancel this thread so that this doesn't run. So let's sleep for 3 seconds, print it, sleeping for 3 seconds, and then cancelling the timer thread. And the way you do it is you say thread.cancel. Let's see if this works. Now as you can see here, the task did not get executed because we cancelled it beforehand. So that we could use here in our game. So what we will do is that uh, we will wait for this answer thread, and in order to do that we will be using join method to wait, and then as soon as this finishes uh, we will cancel the timer thread because we don't want to print the time is up because this has returned. Right. So let's check it out how it works, then we can proceed forward. So let's run this. So 6 plus 2 and my time is up. Now as you can see, it has printed the message time is up after 3 seconds, uh, but the program is still running, it has not exited out. The reason being that since we are waiting on the join, this is a blocking call, right? And we did not even get the time to the control did not even reach here to cancel the timer thread. So we are still here in thread.join, and in this user answer we are here, we are waiting on line number 10 to get user input. So if I give some input, let's say 678, and it again continues because we have a for loop here. So now once I give it the answer, it again continues the same process again. So clearly we have a problem here. So let's fix that problem. The join method also has a timeout value which we could utilize. So what we could do is, instead of waiting indefinitely for the user to give the input or for the answer thread to finish, we will say that let's wait for um, ideally it should be 3 seconds. We should wait for 3 seconds and then cancel the thread, but let's wait for 4 seconds so that the timer thread gets a chance to do its job. Now, in the time is up, let's maintain a global variable that tracks whether the game is over, and let's make it false for now. And over here, as soon as we print that our time is up, we will set the global game over to game over is equal to true. Alright, so now if our timer thread it ran, it will print the message. Let's make a new line as well. It will print this message, time is up, and then it will also set the game over flag as true. And now we could check here, after waiting for 4 seconds, we could check here whether the game over flag is true. So if the game over flag is true, we should break out. And if the game over flag is not true, then that means the timer thread hasn't run yet. So we could cancel it. So that means the user gave the answer before 3 seconds. So let's verify if this is working. Let's take the easy case first. Let me terminate this. So let's wait for 3 seconds. Time is up and the score gets printed. But there is still a problem here. The program did not come out. You see, it did not exit. And when I try to enter something, it says it gives me an error. So it's still expecting. So it's still waiting here for the input. Now, the reason uh, why it is doing is because this is a non-daemon thread, this answer thread. What we would like to do is, as soon as the control reaches here, the main thread, this user thread should also terminate. So in that case, if we add a daemon equal to true here, what will happen is, as soon as we print score equal to 0, or whatever the score is, this thread will automatically get killed. So that means we will not be waiting over here, and the program should hopefully exit. So let's check that. Let me run this. And there you have it. So it ran, it printed your time is up, and the score value is 0. So let's test a positive case. I have to be quick in this. 7, it's 9, 6, and 6. It exits out, and let's give one negative. Let's give a wrong score as well. Maybe 8, 7, and 3. Okay, the score is correct. And also let's give a timeout on the last value. Yeah, let's make it so it says time is up and it prints the score and exits out. So this is working. So now, just to give a summary what we are doing here, we are taking 3 tests of the user by providing single digit number, single digit addition. In that we are creating 2 threads. One thread will ask the user for the input. It will generate a random question and ask the user for the input, and the other thread will run after a set interval to mark the game as over if the time has exceeded. The way this works is, we wait for the answer thread to come back to us. If it comes back to us in such a way that the timer thread did not execute, then we immediately cancel it because we don't want it to execute, and we will cancel it. But if this returns 4 seconds, if this returns, where the timer has executed and has marked the game as over, then in that case we break out because the game is over and we print the score. However, although we have waited for 4 seconds, but the thread is still running waiting for the user's input, we would like to terminate it as well. So that's why we marked it as a daemon, so that as soon as the control reaches here, the thread exits.